Hello there, and welcome to the Sleepy Space Channel. Almost every picture of the universe tells the same quiet lie. It shows a sky that is crowded with stars and galaxies, full of light from edge to edge, when the truth is that the cosmos is made almost entirely of emptiness. Tonight, we climb a ladder of distance, outward from our own doorstep, and each rung is so much larger than the one before it that your sense of scale will quietly reset, again and again. We will pass the edge of the solar system we have never seen, the nearest star we could not reach in 70,000 years, the lonely galaxies adrift in voids, hundreds of millions of light-years wide, and at last the wall of time at the edge of everything we can ever observe. If you find these slow journeys worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of these distances is anything you need to carry. There is nothing out there you must reach, and nothing here you must remember. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade gently away. Let's begin. Most images of the universe show the same thing. They show galaxies and stars and light scattered across the frame, a sky that looks crowded and full, as though the cosmos were a place packed close with bright and busy matter. That impression is, in the gentlest sense, false. The universe is not crowded. It only seems that way because the eye is drawn to the few places where matter has gathered, and it cannot see the overwhelming emptiness that lies between them. The numbers behind this are sobering in their own quiet way. Everything that can be seen or touched, every star and planet and moon, every grain of dust and every atom of every living thing, belongs to a single category that astronomers call ordinary matter. By the best estimates available, all of that ordinary matter makes up less than 5% of the universe. The bright, touchable, knowable part of the cosmos is a thin minority riding on top of something far larger and entirely unseen. The rest is divided between two things we have never directly observed. Roughly a quarter of the universe appears to be dark matter, a kind of mass that gives off no light and reflects none, yet makes itself known through the pull of its gravity. The remaining and largest share is dark energy, a property of space itself that drives its slow expansion. No one has ever seen either one. We know they are there only because, without them, the motions of galaxies and the stretching of space would not add up. Dark matter reveals itself through a single stubborn fact. Galaxies spin far too quickly to hold themselves together on the strength of their visible stars alone. They rotate as though a much greater unseen mass were wrapped around them, holding the fast-moving outer stars from flying off into the dark. That unseen mass has never been caught in any instrument, yet its grip is written into the turning of every galaxy we can measure. Dark energy reveals itself in an even stranger way. The space between distant galaxies is not merely large, it is growing, and the growth is speeding up. Something is pushing the universe apart faster and faster as time goes on, and that something has been given the name dark energy for lack of any deeper understanding. It is the most abundant ingredient in all of reality, and it remains almost completely mysterious. So the part of the cosmos this entire journey is about is a faint, bright island in a far greater darkness. And even that small fraction of ordinary matter is not spread out evenly. It does not fill space, like fog filling a valley. Instead, it clings together along the edges of enormous, empty regions, leaving most of the volume of the universe untouched, dark, and still. What we see when we look up at night, those points of light and faint smudges of distant galaxies, is the exception and not the rule. It is the foam riding on the surface of an ocean of void. The stars are real, and the galaxies are real, but they are the rare gatherings, and the emptiness between them is the true substance of the universe. The real question of this night is not how many things there are. It is how far apart they sit, and how profound the emptiness between them truly is. There are two honest ways to ask that question. One is to recite enormous numbers until they begin to sound impressive and then stop meaning anything at all. The other, the one we will follow, is to climb slowly, one distance at a time, pausing at each step until the size of it has settled before reaching for the next. We begin somewhere small and familiar, and we let each rung of the ladder quietly undo our sense of the one before it. The strange comfort of this climb is that the emptiness is not a danger. The distances are too great for anything to ever cross, and that very fact means that nothing out there is rushing toward us. The void is patient. It has been arranged this way for billions of years, and it will stay this way for billions more. To understand its scale is not to be frightened by it, but to feel how much quiet room the universe has made, and how rare and small and warm our own lit corner of it really is. It helps to dwell on that figure of 5%, because it is easy to read and hard to truly feel. Imagine everything that has ever been seen by any eye or any instrument, every star catalogued, every galaxy photographed, every world and moon and grain of dust. Set all of it on one side of a scale. That entire bright inventory of the cosmos is less than a 20th of what the universe actually contains. The other 19 parts are unseen, made of things we can only infer. The dark matter that makes up the larger share of mass is not rare or hidden in distant corners. It is woven through everything, including the space around us, passing through the earth and through our own bodies without a trace. It does not shine, it does not block light, and it barely interacts with ordinary matter at all. We move through an ocean of it constantly, and we feel nothing, because its only firm signature is the gentle pull of its gravity across the scale of whole galaxies. Around every galaxy, this dark matter forms an enormous, unseen halo, far larger than the bright disk of stars at its center. The visible Milky Way, the band of light across our sky, is only the glowing core of something much greater, a sphere of invisible mass that reaches out many times further than the stars. The galaxy we can see is the lit center of a structure mostly made of something we have never directly held. Dark energy is stranger still, because it is not a kind of matter at all, but a property of empty space itself. Each region of vacuum appears to carry a faint, steady push outward. And because the universe holds so much vacuum, that gentle pressure becomes the dominant force shaping the cosmos as a whole. The emptiness is not passive. The very nothing between the galaxies is what drives them apart. So the picture sharpens into something almost upside down from the one we begin with. We tend to imagine space as the empty stage and matter as the real performers upon it. But the emptiness has its own substance and its own influence, and the bright matter is the thin exception scattered through it. The stage is the story, and the actors are a faint dusting of light across a darkness that does almost all of the work. There is no need to hold any of these terms firmly tonight. Dark matter, dark energy, ordinary matter, these are only names for the proportions of a cosmos that is mostly distance and mostly unseen. What matters for the climb ahead is the simple shape of it. The universe is enormous. It is overwhelmingly empty, and the few bright things within it are spread impossibly thin across that emptiness. Even the bright matter, that small 5%, is gathered into the thinnest of arrangements. It does not fill its share of space evenly. It collects along walls and threads, leaving the great interiors bare, so that even within the visible cosmos, most of the volume holds almost nothing. The exception is itself riddled with emptiness, bright only along its edges, dark through all its middle. This is why the climb must be taken slowly, one rung at a time. The distances ahead are not the kind that can be felt all at once, by reciting a final enormous number and being done. They have to be approached step by step, each one settling before the next, until the sheer proportion of emptiness to light becomes something the mind can rest against rather than recoil from. We begin where the emptiness is gentlest, in the warmth of our own small star. There is a humility in beginning here, with the plain fact of the proportions. Before any single distance is named, the shape of the answer is already set, because the cosmos has chosen emptiness as its main material and light as its rare exception. Everything that follows tonight is a slow unfolding of that one truth, distance after distance, each larger than the last. We are not climbing toward a crowded destination. We are climbing into ever greater openness, ever deeper stillness, ever wider gaps between the few lit things. And the further we climb, the more clearly the emptiness shows itself to be not a flaw in the universe, but its very nature. So let the sky look crowded for a little while longer, the way it always has. Then let that picture loosen. Behind the bright and friendly stars lies the real architecture of the cosmos, which is distance and separation, and a stillness so wide that light itself spends most of its existence traveling through nothing at all. We will start at home, where the emptiness is gentlest, and we will work outward from there. We begin somewhere that feels small, because almost everyone underestimates how large even our own neighborhood is. The solar system is the one piece of the universe that humanity has actually visited, the only region where our machines have ever flown. And it is already far too large to cross in a single human lifetime, by a margin that is difficult to hold in the mind. The first ruler we need is light itself. Light is the fastest thing the universe permits, and nothing with mass can ever match it. Yet even light is slow once it sets out across real distance. Sunlight takes about 8 minutes to travel from the sun to the earth. This means the sun you picture in the daytime sky is always around 8 minutes old, an image that left its surface before you looked. To reach the orbit of distant Pluto, that same sunlight needs more than 5 hours. Pluto circles the Sun at an average distance of roughly 6 billion kilometers, far enough that the warmth and brightness we take for granted have dwindled to almost nothing by the time they arrive. From here outward, kilometers stop being useful. The natural ruler becomes the light travel time, the simple measure of how long light has been on its way to reach a place. Now consider how the fastest things we have ever built compare to that ruler. The quickest probe ever launched from the Earth, a small craft sent to study the outer worlds, took about 9 years to reach Pluto. 9 years of continuous flight at a speed no human vehicle had ever exceeded, simply to arrive at a world that still lies well within our own solar system. And when that probe finally arrived, after nearly a decade of travel, it had only about 30 minutes near its target to gather its most valuable close-up measurements. 30 minutes, after 9 years, before the encounter was over and the craft swept past and onward into the darkness beyond. There was no slowing down, no orbit, no second look. The distances are so large that even arriving is only a brief passing. Pluto, though, is nowhere near the edge of the solar system. It is simply the last of the familiar worlds, the final stop on the map most people carry in their heads. Far beyond it lies the true outer boundary, and the gap between Pluto and that boundary is itself larger than everything we have just described. The map most of us learned ends long before the solar system actually does. Consider the most distant machine humanity has ever made. A pair of probes, launched decades ago to tour the outer planets, did not stop when their tour was done. They kept going, outward and outward, and one of them is now the farthest human-made object in existence, around 23 billion kilometers away and still moving. It has crossed beyond the region where the sun's wind holds sway, into the space between the sun and the stars. And yet, by the true measure of the solar system, even that probe has barely left home. It has been flying for the whole of its long mission, faster than almost anything we have ever built, and it has only just begun to cross the threshold of the sun's outermost domain. Everything we have ever launched, every probe and lander and flyby, has stayed within this one small, familiar pocket of space. There is a quiet lesson already in this first rung of the ladder. The solar system is the part of the universe we know best, the part we have touched, and it is still so large that 9 years of flight reaches only its middle distances, and decades of flight only its inner edge. If this is the small and homely beginning, the place where the emptiness is gentlest and most familiar, then the distances ahead must be approached slowly and with care. To feel the size of the solar system, it helps to shrink it down to something the mind can hold. Imagine the sun reduced to the size of a small coin held in the hand. On that scale, the Earth would be a grain of dust a few paces away, and the warmth of the coin would be all the sunlight that grain ever received. The whole inner family of worlds would fit within a small room. But on that same scale, distant Pluto would lie far down the street, a tiny speck many hundreds of paces from the coin. The fastest probe we ever built, crossing that distance in 9 years of real flight, would be inching along the pavement the whole time. And the true edge of the solar system, the outer shell we will reach in a moment, would lie kilometers away from the little coin, far past the end of the street and out of sight entirely. Between the worlds, there is almost nothing. The space between the planets is not crowded with debris or dust, but is, for the most part, simple emptiness. Even the belt of asteroids, often pictured as a dense field a craft must thread carefully through, is so sparsely scattered that a probe passing through it is unlikely to come anywhere near a single rock. The asteroid belt is mostly the gap between asteroids. Light measures these gaps better than kilometers do. Sunlight reaches the inner worlds in minutes, but it takes more than an hour to cross to the ringed giant, and several hours to reach the outer planets beyond. A message sent from a probe at the edge of the solar system, traveling at the speed of light, takes most of a day to reach the Earth, so that every command and every reply is separated by hours of waiting as the signal crawls across the emptiness. The planets themselves are separated by gulfs far larger than their own sizes. The gap between the ringed giant and the world beyond it is greater than the entire distance from the Sun to the inner planets. Each step outward is larger than all the steps before it combined, so that the map of the solar system is not evenly spaced, but stretches and thins as it goes, the worlds growing lonelier the further out they lie. Surrounding all of this is a great bubble blown by the Sun itself, a region filled with the steady wind of particles streaming off its surface. This bubble holds back the thin gas of interstellar space and marks the limit of the Sun's direct influence. The most distant probe crossed the edge of that bubble only after decades of flight, passing from the Sun's wind into the quiet of the space between the stars, a boundary it took a working lifetime to reach. And yet even that boundary is not the true edge of the solar system. It is only the limit of the Sun's wind, far short of the limit of the Sun's gravity. Past it the planets end, the wind ends, and still the Sun holds sway over a great shell of icy bodies, reaching outward for a long way yet. The familiar map, with its 8 or 9 worlds, ends long before the sun's domain actually does. There is a quiet patience in all of this that is worth carrying upward. Our fastest machines, flying for years and then decades, have only begun to cross the nearest part of the cosmos, the one small pocket lit by our own star. The solar system is the easy rung, the homely beginning, and it is already too large for any human journey to cross within a life. We hold that humbling fact, and we step outward to the shell that marks the true edge of home. It is worth remembering, as we leave the solar system behind, how thoroughly it has been our whole world until now. Every footprint, every machine, every signal we have ever sent has stayed within this one small pocket of the cosmos, lit by this one star. The probes still traveling outward carry the only physical trace of us that has ever approached the edge of it, and even they have barely begun to leave. The solar system is the one room of the universe we have actually touched, and it is already too large to cross in a life. We carry that scale upward with us as the smallest measure on the ladder, the gentle first rung against which all the rest will be judged. So hold the image of that probe for a moment, still out there tonight, drifting through the cold at the rim of the sun's reach. It is the farthest we have ever sent anything, and it is still inside our own solar system, still bathed faintly in the light of our own star. That single present tense fact that it is out there now and still has not truly left is the first gentle resetting of scale. From here, the ladder begins to climb in earnest. Pluto is not the boundary, and neither is the most distant probe. Far beyond both lies the true outer shell of the solar system, a structure so large that it surrounds the sun and every planet at once, like a faint sphere enclosing everything we have ever known. It is called the Oort cloud, and by current estimates, it may reach as far as a full light-year from the sun, nearly a quarter of the way to the nearest other star. The Oort cloud is thought to be an immense swarm of icy bodies, the frozen leftovers of the solar system's birth. Long ago, when the planets were forming, countless small worlds of ice were flung outward by the gravity of the giant planets and left to drift far from the warmth. They settled into enormous, slow orbits, and there they have remained, circling the sun across spans of time so long that a single orbit can take millions of years. The strangest thing about this outer shell is that no one has ever seen it. Not a single telescope has imaged the Oort cloud directly. It is too far, too dark, and too thinly spread for its bodies to be detected across such distance. Everything we believe about it is inferred, reconstructed from indirect evidence the way one might reconstruct a far shore from the driftwood that washes up. That evidence comes from comets. Every so often, one of those distant icy bodies is nudged from its slow orbit and begins the long fall inward toward the sun. As it approaches, it warms, it brightens, and it becomes a comet visible from the Earth. From the angles these comets arrive at and the immense intervals of time between their visits, astronomers have worked backward to the shape of the shell they must come from. The Oort cloud is a model built from comets, not a place anyone has ever photographed. Its size is difficult to state in a way that lands. If the solar system we mapped in the last part already felt large, the Oort cloud dwarfs it completely. The planets, the distant probe, the whole region we have ever explored would all fit into the small central space at the very heart of this enormous icy sphere. The cloud is not a ring at the edge of things. It is an enormous hollow shell with everything familiar tucked far inside it. To feel its depth, return to the fastest machine we have ever launched, the distant probe still flying outward tonight. Traveling at its current speed, that probe would need something on the order of 30,000 years simply to pass through the full depth of the Oort cloud. 30,000 years of continuous flight, just to cross the outermost layer of our own solar system and emerge on the far side. 30,000 years is longer than the whole of human civilization many times over. It is longer than recorded history, longer than agriculture, reaching back into an age when our ancestors were painting on the walls of caves. And that is the span needed merely to traverse the final shell of our own star's domain, the part of the solar system we have never even seen. Of everything that lies out there, in the true outermost reaches of the place we call home, we have explored essentially nothing. The Oort cloud is the edge of our own backyard, and it remains entirely unvisited, known only through the comets that occasionally drift in from it, like messages from a coastline beyond the horizon. It marks the line where the familiar genuinely ends. There is something worth resting in here before we go further. The boundary of our own solar system is a place we have never observed and could not reach in the span of all our history laid end to end. It is not hidden by any great mystery. It is simply far, so far that distance alone has kept it beyond us. And it is still the nearest of all the distances we will meet tonight, the closest rung on a ladder that has only just begun to climb. The Oort cloud is best imagined not as a ring, but as a great hollow sphere surrounding the sun on every side at once. The planets all lie in a flat plane, circling the sun like markings on a single broad disk. The Oort cloud is different. It wraps around the whole solar system in every direction, above and below and around, a faint shell of ice enclosing everything familiar far within it. Some astronomers picture it in two parts, an inner region shaped more like a thick disk, and an outer region that is the true surrounding sphere. The inner part begins far beyond the planets, and the outer part reaches out toward that full light year from the sun. Across this enormous span drift uncounted icy bodies, perhaps trillions of them, each one alone in its own great pocket of space, separated from its nearest neighbor by distances larger than the whole inner solar system. From a body out in the Oort cloud, the sun would not look like the sun at all. It would be only a particularly bright star, a single sharp point of light among the others, giving no warmth and casting no glow. There would be no daytime there, no sky, no sense of belonging to a sun and its planets, only the faint, distant star that holds the icy body in its slow orbit across millions of years. The orbits out there are almost beyond patience. A single trip around the sun for a body in the outer Oort cloud can take millions of years to complete. A comet that falls inward toward us now last passed this way before there were people to see it, and will not return again until long after every present memory is gone. The clock of the outer solar system turns so slowly that a single tick of it outlasts whole chapters of life on the Earth. Because the cloud reaches so far from the sun, its outermost bodies are only loosely held. The gentle gravity of other stars passing at a distance and the slow tides of the galaxy itself are enough to nudge those distant comets, tipping a few of them inward toward the sun or loosening others away into interstellar space entirely. The edge of our solar system is soft, blending gradually into the space between the stars, rather than ending at any sharp line. This is how the cloud makes itself known to us. Now and then, one of those nudges sends an icy body on the long fall inward, and after a journey of immense duration, it nears the sun, warms, and grows a tail, becoming a comet in our sky. Each such comet is a single messenger from the outer shell, carrying in its orbit the faint signature of the place it came from, a place we have never otherwise seen. From these messengers, and from them alone, the whole picture of the Oort cloud has been assembled. Its size, its shape, its distance, all of it is reconstructed from the paths of comets and the long intervals between their visits. No telescope has confirmed it directly, and perhaps none ever will. It is the most distant feature of our own solar system, and it remains a thing inferred rather than a thing observed, a far coastline known only by its driftwood. And so the true edge of home is a shell we have never seen, reaching a quarter of the way to the nearest star, holding its slow comets in orbits that outlast civilizations. To cross, it would take our fastest probe 30,000 years, and to see it directly may take longer still. It marks the line where the familiar finally ends, and beyond it lies the first of the truly interstellar distances, the gap to another sun. The Oort cloud teaches a lesson that the rest of the climb will only deepen, which is that the universe keeps its edges soft and far. There is no wall at the boundary of the solar system, no clear line where home ends and the wider cosmos begins. Only a slow thinning of icy bodies across a light year of darkness, blending gradually into the space between the stars. The place we call home does not stop sharply. It fades across distances so great that we have never seen the fading happen. And this softness, this gradual giving way of the familiar to the unknown, is how every boundary in the universe is built, by distance rather than by any edge. So picture that faint shell of ice, surrounding the sun and all its worlds, holding its slow comets in orbits that outlast empires. It has been there since the beginning, patient and unseen, marking the true edge of home. Beyond it, the solar system ends, and the next thing is not another planet or another probe. The next thing is another star, and the distance to it is of an entirely different order. Past the Oort cloud, the familiar ends completely. There are no more planets, no more icy shells, no more pieces of our own sun's household. There is only the open space between the stars, and the nearest other sun lies about 4¼ light-years away. To say that plainly, the closest star to our own is more than 4 years of travel away, even for light itself, the fastest thing that exists. It helps to make the light year real before going on. A light year is simply the distance that light covers in a single year of unbroken travel. Light moves fast enough to circle the Earth many times in 1 second, and yet in a year it crosses a distance of roughly 9.5 trillion kilometers. The nearest star is more than 4 of those light years off, which is to say, more than 4 times 9.5 trillion kilometers of empty space. Now place a human machine against that distance. Traveling at the speed of the fastest probe we have ever built, the journey to the nearest star would take something on the order of 70,000 years. Not 70 years, but 70,000, an interval so long that the people who set out would belong to a different age of humanity entirely from the ones who might one day arrive. To feel that span, look backward instead of forward. The whole of recorded history, every written word and remembered name, covers only a few thousand years. The great ancient empires lie just 2,000 years behind us. 70,000 years reaches back many times further than all of that, into the dim beginnings of our own kind. We would not arrive at the nearest star with anything we currently know how to build, and the trip would outlast civilizations. And this, remember, is the near one. The nearest star of them all, the closest other sun in the entire universe to our own, is already this unreachably far. Every other star in the night sky lies further still, most of them vastly further. The 4¼ light-years to our nearest neighbor is the smallest gap there is between one star and the next, and it is already beyond any journey we could make. The nearest star turns out to be a quiet and interesting place in its own right. It does not travel alone. It belongs to a system of 3 stars bound together by gravity. 2 of them, both somewhat like our own Sun, orbit each other closely, circling in a slow waltz. The nearest star itself is the 3rd member, a smaller companion bound to that central pair at a great distance, drifting around them across an immense span of time. It is a particular kind of star called a red dwarf, smaller and cooler and dimmer than our own Sun, but far longer lived. Red dwarfs burn slowly and patiently, lasting for spans of time that dwarf the present age of the universe. The nearest star will still be shining long after our own Sun has run its course, a small, steady ember in the dark, outlasting nearly everything around it. There is even a planet circling that nearest star, orbiting at a distance where temperatures might, in principle, allow water to remain liquid on its surface. For a moment, that sounds like a doorway, a possible second home only 4 light-years off. But red dwarfs are restless stars. They release strong flares of radiation, sudden surges of energy that wash over their nearby worlds again and again, and a planet so close would likely be scoured by that radiation many times over. Whether life could ever take hold on such a world remains genuinely uncertain. The planet sits in the right place for warmth, yet it may be bathed too often in its star's harsh flares for anything delicate to endure. This is one of the quiet, open questions the universe has not answered for us, hanging over the nearest planet around the nearest star, 4¼ light-years and 70,000 years of travel away. It is worth lingering on what 4¼ light-years really separates. If the Sun and the nearest star were each shrunk to the size of an orange and placed at their true relative distance, the 2 oranges would sit thousands of kilometers apart, with nothing but empty air between them across the whole span of a continent. That is the spacing of stars, even the closest ones, 2 small warm fruits separated by an emptiness larger than any country. The nearest star is so faint that despite being the closest of all, it cannot be seen from the Earth without a telescope. It is a small red dwarf, dim and cool, and its light is too weak to reach the unaided eye across 4 light-years of space. The closest other sun in all the universe is, to our own eyes, invisible, hidden in the glare of its 2 brighter companions and lost against the dark. Those 2 companions are a closely matched pair, both broadly similar to our own Sun, circling each other across a span of decades. From a world in that system, the sky would hold 2 suns rather than 1, sometimes close together and sometimes apart, casting double shadows and turning through the day in a slow dance. It is a different kind of sky from ours, and it is the nearest sky there is beyond our own. From a planet circling the nearest star, our own Sun would appear as nothing more than a bright point of light, 1 star among the patterns of that alien sky. The warmth we live by, the light that fills our days, would be reduced across 4 light-years to a single faint spark, indistinguishable at a glance from any other star. To them, if any could look, we would be the distant and unremarkable neighbor, a dim point in their night. The light leaving our Sun tonight will take more than 4 years to reach that nearest star. A flash sent from the Earth now would arrive there only after 4 years of travel, and any answer would take 4 more years to return. Even at the speed of light, the fastest exchange possible, a simple greeting and reply between the nearest stars would take longer than a childhood. The distances impose a slowness on everything, even on light, even on the simplest conversation. This is why the dream of crossing to another star runs into the plain arithmetic of distance. To reach the nearest star within a human lifetime would require speeds far beyond anything ever built, a fraction of the speed of light itself, and the energy needed to reach such speeds is enormous beyond present means. At the speeds we can actually achieve, the journey would span tens of thousands of years, longer than the whole history of our kind. And the nearest star is only the first of an uncountable host. Behind it lie the other near stars, a handful within a dozen light-years, and behind them thousands within 100, and behind them the hundreds of billions that make up the galaxy. The 4¼ light-years to the closest sun is the smallest gap in that entire host, the easiest interstellar step there is, and it is already beyond any reach we possess. So we hold the nearest star as it truly is, a faint red ember invisible to the eye, bound to a pair of brighter suns, circled by a battered world that may be too harshly lit for life. It is the closest other star in existence, 4 light-years and 70,000 years of travel away, and it stands at the threshold of the galaxy. Beyond it, the stars multiply past counting, and the next rung of the ladder takes in all of them at once. The nearest star stands as the threshold of the whole interstellar realm, and crossing that threshold in the mind is the hardest step of the early climb. Up to here, the distances belong to our own household, the worlds and shells of our own sun. Now we have stepped into the open space between suns, and the first thing we find there is that even the nearest neighbor is 70,000 years away. Every step from here outward will be measured in these interstellar gulfs, and they will only widen. The nearest star is the smallest of them, the easiest leap there will ever be, and already it lies beyond the reach of any journey we could make in the span of all our history. So hold the whole picture of this rung together. The closest other sun is part of a triple family of stars, one of them an ancient, slow-burning ember with a single warm and battered planet that may or may not be able to hold life. It is the nearest thing of its kind in all of existence, and it is already past the edge of any journey we could undertake. From here, the ladder climbs again, and the next step is not one star, but hundreds of billions of them. Once the distance to a single neighboring star has settled in the mind, the size of the galaxy can be approached honestly. The Milky Way holds somewhere between 200 and 400 billion stars, a number so large it seems to promise a sky packed close with suns. The truth is the reverse. The galaxy is not a dense crowd of stars. It is an enormous emptiness with stars scattered thinly through it. We have already met the measure that proves this. The nearest star to our own sits more than 4 light-years away, and that spacing is typical. In our region of the galaxy, the average distance between one star and its neighbor runs to several light-years of open space. Stars are not packed shoulder to shoulder. Each one floats alone in its own wide pocket of emptiness, separated from the next by distances that light itself takes years to cross. This thin spacing has a strange and calming consequence. Galaxies do collide. Our own Milky Way is on a slow course to merge with its largest neighbor in a few billion years, the two great spirals drifting together under gravity. And yet, in such a merger, the chance that any two individual stars actually strike one another is so small as to be almost nothing. The stars are simply too far apart, too thinly spread, for collisions to matter. A collision between galaxies, then, is not a smashing of suns. It is the slow flowing together of two clouds of mostly empty space. The stars of one galaxy pass between the stars of the other like two handfuls of sand thrown across a stadium, almost none of the grains ever meeting. Over hundreds of millions of years, the two galaxies merge and settle into one, and through all of it, the individual stars sail on untouched. Even the great collisions of the cosmos are gentle, because the emptiness is so wide. The shape of the Milky Way is also less simple than the smooth pinwheel of popular imagery. It is not an even disk. It has a central bar of stars stretched across its core, spiral arms winding outward from that bar, a thickened bulge of older stars swelling at the center, and surrounding the whole structure, a faint halo of ancient stars and dark matter, like an atmosphere wrapped around the bright disk. At the very center of the galaxy sits a supermassive black hole, a region of gravity so concentrated that not even light escapes it, holding the mass of about 4 million suns within a space smaller than a single star system. Everything in the galaxy, every one of those hundreds of billions of stars, slowly circles that central point, carried around on orbits that take many millions of years to complete. Our own place in all of this is quietly unremarkable. The sun lies out toward the edge of one of the spiral arms, neither in the bright, crowded center nor at the absolute rim, but somewhere in the calm middle distance. It sits about 26,000 light-years from the galactic core, in a galaxy that is itself, between its stars, made mostly of empty space. We are not at the heart of things, and not at the edge, but in the quiet in between. The size of the galaxy is its own kind of statement. The Milky Way measures roughly 100,000 light-years across, and by some newer estimates, perhaps twice that figure. To cross it once at the speed of light, the very fastest motion that reality allows, would take 100,000 years. A beam of light setting out from one edge of the galaxy would not reach the far side until 1,000 centuries had passed. It is worth saying plainly and softly what the speed of light really is. It is not a technical hurdle that some future engine might overcome. It is a built-in limit of the universe itself. The closer anything with mass comes to that speed, the more energy is needed to push it even slightly faster, and to actually reach the speed of light would require an infinite amount of energy. The slowness we feel against these distances is not a failure of our machines. It is woven into the structure of reality. The sun does not sit still within the galaxy. It moves, carried along on its great orbit around the distant core, sweeping through space at a speed of well over 200 kilometers every second. We feel none of it, just as we feel none of the Earth's spin. Yet at this very moment, the whole solar system is racing through the galaxy at a pace that would cross a country in a heartbeat. Even at that enormous speed, a single orbit around the galaxy takes a very long time. The sun needs something like 225 to 250 million years to complete one circuit of the galactic core. This span is sometimes called a galactic year, and by its measure the sun is middle-aged, having circled the galaxy only about 20 times since it first formed. The galaxy turns so slowly that 20 of its years span the whole life of our star. When the sun last passed through the part of its orbit it occupies now, the Earth was a different world entirely, its continents in other places, its seas full of creatures long since gone. A single turn of the galaxy is longer than the rise and fall of whole kingdoms of life. The wheel is so large that even racing along it at 200 kilometers a second, we take 250 million years to come round once. The disk of the galaxy is broad, but surprisingly thin, like a great platter of light. Its 100,000 light-year width is matched by a thickness of only a small fraction of that, so that the galaxy is a wide, flat structure rather than a round ball. We live within the thin, bright plane of it, which is why the galaxy appears to us as a band stretched across the sky, the disk seen edge-on from our place inside it. Around the flat disk lies a much larger spherical halo, faint and old. Scattered through this halo are the globular clusters, dense balls of hundreds of thousands of ancient stars, among the oldest things in the galaxy, orbiting far out beyond the bright spiral arms. They are like quiet villages of elder stars, set apart from the busy disk, circling the galaxy on long, slow paths through its outer reaches. The galaxy does not travel alone either. It is trailed and orbited by a retinue of smaller satellite galaxies, dwarf companions bound to it by gravity, some of them slowly being pulled apart and absorbed into the larger whole. Long streams of stars trail across the sky, the remains of smaller galaxies the Milky Way has drawn in and is gently unraveling, woven now into the body of our own. All of this, the disk and the arms and the bar and the halo and the satellites, turns around that single dark center, the supermassive black hole holding the mass of 4 million suns. The whole enormous wheel of hundreds of billions of stars is anchored to that one unseen point, every star tracing its slow orbit around it. The entire galaxy, a single enormous structure turning in the dark across hundreds of millions of years. And the Milky Way, for all its size, is only one galaxy among an uncountable number. Its 100,000 light-years, its hundreds of billions of stars, its slow quarter-billion-year turns, all of it is a single island of light. We have climbed from a coin-sized sun to a wheel 100,000 light-years wide, and we are still only at one island among trillions. The next rung lifts us off the island entirely and into the space between galaxies. The galaxy gathers all of these threads into a single turning whole, and our place within it is the quietest kind of ordinary. We are not at the bright center where the stars crowd close, nor at the faint rim where they thin to nothing, but out in a calm middle stretch of one spiral arm, carried slowly around a circuit that takes 250 million years. The sun has made that circuit only about 20 times in all its life. The galaxy turns so grandly and so slowly that whole eras of the Earth pass within a single one of its years. We ride that great wheel without feeling it, one small star among hundreds of billions, in a structure mostly made of the space between its stars. There is rest to be found in that, rather than frustration. The galaxy is mostly emptiness, so spacious that even its collisions are emptiness, meeting emptiness, and its scale is held in place by a law of nature that no cleverness will ever undo. We live far out in one of its arms, on a small world circling an ordinary star, in the quiet middle of 100,000 light-years of slow-turning space. And the Milky Way, enormous as it is only a single galaxy. The next rung of the ladder steps beyond it entirely. Beyond the Milky Way lies the next great rung of the ladder, and it asks the mind to stretch once more. The nearest large neighboring galaxy sits about 2.5 million light-years away. On a clear, dark night, far from city lights, it can just be seen with the unaided eye, a faint, pale smudge against the black. That smudge is not a star and not a cloud. It is an entire galaxy of hundreds of billions of suns. To see it at all is to perform a kind of time travel. When that faint light enters the eye, it has been traveling for 2.5 million years. It left its galaxy and crossed the emptiness between for all of that time, and only tonight arrives. The light you would catch from it, set out before our own ancestors had learned to shape the simplest stone tools. To look at the nearest galaxy is to look 2.5 million years into the past, and there is no other way to see it. This is true of everything in the night sky to some degree, but at this distance it becomes vivid and undeniable. Nothing in the far sky is seen as it is now. The starlight that reaches us is always old, sometimes by years, sometimes by centuries, and here by millions of years. We do not see the universe in the present tense. We see a gallery of the past, each object shown to us as it was when its light departed, never as it is tonight. The Milky Way and that great neighbor are bound together by gravity, the two largest members of a small gathering of galaxies. This gathering is called the local group, and it holds roughly 50 galaxies within a span of about 10 million light-years. Most of them are small, faint dwarf galaxies, modest companions orbiting the two giants. Together they form a single loose island of galaxies, drifting through the larger emptiness as one. 2.5 million light-years between the two great galaxies, 10 million light-years across the whole island, and these are now the small distances. The spacing between stars, which once seemed unimaginable, has become a local detail. The width of the entire Milky Way, 100,000 light-years, is now only a fraction of the gap to a single neighbor. The ladder has a way of making each previous rung shrink to nothing as soon as the next one is reached. Beyond the local group, the emptiness opens again. Past our small island of 50 galaxies, there is a great stretch of nearly nothing, and then the next comparable gathering of galaxies. That next cluster lies around 65 million light-years away, far beyond our own little group, a separate and much richer city of galaxies drifting in its own region of space. Between us, and it lies mostly void. The pattern that began in the solar system now repeats at a scale almost beyond holding. There are rare gatherings of light, the clusters and groups of galaxies, and between them far greater stretches of emptiness. At every level of the ladder, the same shape appears. Matter draws together into small, bright islands, and around those islands lies an ocean of distance, many times larger than the islands themselves. It is worth pausing on the nearest galaxy itself, that pale smudge 2.5 million light-years off. It is a great spiral much like our own, turning slowly, holding its own hundreds of billions of stars, its own central black hole, its own quiet planets we will never see. And it is drifting toward us, slowly, across the emptiness, on the long course that will one day bring the two galaxies together into a single greater whole. But that meeting lies billions of years ahead, and tonight it is only a faint light in the dark. There is a particular stillness in this rung of the ladder. The photons entering the eye from the nearest galaxy are older than our entire species. They began their crossing before there was anyone here to one day catch them, and they have traveled, untouched, through millions of light-years of emptiness to arrive on this single night. To see that smudge is to receive something ancient, sent before we existed, arriving exactly now. The nearest great galaxy is not only visible to the eye, it is far larger in the sky than most people ever realize. Its faint smudge marks only the bright central core. The full disk of that galaxy, if our eyes were sensitive enough to catch its dim outer reaches, would stretch across a span of sky several times wider than the full moon. An entire galaxy hangs there in the dark, most of it too faint to see, far larger than it appears. That galaxy is a great spiral much like our own, perhaps somewhat larger, holding its own hundreds of billions of stars. It has its own spiral arms, its own central black hole, its own quiet retinue of satellite galaxies, its own slow turning across the ages. It is the nearest thing to a twin our galaxy has, a mirror of the Milky Way set 2.5 million light-years off, drifting in the same small island of galaxies as we do. The two great spirals are not drifting apart, but slowly toward each other. Across billions of years they will approach, pass through one another, and at last merge into a single greater galaxy, their stars mingling without ever colliding, their shapes dissolving and reforming into something new. It is a meeting written into the motions we can already measure, though it lies so far ahead that the sun itself will be near the end of its life before it comes. Within the local group, there is a third spiral, smaller than the other two, along with the 50 or so dwarf galaxies that fill out the gathering. Most of these companions are faint and small, modest clouds of stars orbiting the two giants. Together they form a single bound system, held by gravity against the expansion of the wider universe, an island that will stay together even as the rest of the cosmos drifts apart. 10 million light-years is the span of this whole island, and it has become, by now, a small distance on our ladder. The width of the Milky Way, once unimaginable, is only 1/100th of it. The gulf to the nearest star, 70,000 years of travel, is a rounding error against it. Each rung shrinks the last to nothing, and the local group, enormous as it is, will shrink in turn at the very next step. Beyond the bound island, the emptiness stretches wide before the next gathering appears. The nearest large cluster of galaxies, a far richer city than our own modest group, lies around 65 million light-years away, holding many hundreds or thousands of galaxies where our group holds only 50. Between us, and it is mostly void, a great quiet gap that dwarfs the island we live in. The light from that nearest cluster left it 65 million years ago, in an age when the Earth was a different world, ruled by different creatures, its skies and seas unlike anything now. To look toward the cluster is to look back across that immense span of time, the light, a slow messenger carrying an image of the past, arriving only tonight after its long crossing of the emptiness. So the local group settles into place as our true neighborhood, 50 galaxies bound in an island 10 million light-years across, with the nearest comparable city of galaxies far beyond it. We are not at the center of this island, nor at its edge, but one of its two great spirals, drifting slowly toward our twin. And the island itself is only a single feature of something far larger, still, the great web of galaxies that the next rungs will reveal. The local group is the largest thing that will ever truly hold us, the one structure bound tightly enough to resist the swelling of space. Everything beyond it will, in the far future, drift away over the horizon. But the 50 galaxies of our own island are bound by gravity into a lasting whole. They will stay together, eventually merging into a single great galaxy, while the rest of the universe recedes from view. In that sense, this small gathering, 10 million light-years across, is our true and final home, the farthest reach of anything we will ever belong to. Beyond it lies the wider cosmos, magnificent and uncountable, but already, even now, slowly slipping out of our grasp. So hold the local group as one small island, 50 galaxies adrift together in a span of 10 million light-years, with the next island 65 million light-years beyond. This is our true neighborhood, not the solar system and not the galaxy, but this little cluster of galaxies bound loosely in the dark. And it, too, is only a single feature of something far larger. The next rung steps into the space between the galaxies themselves. The emptiness inside a galaxy is profound, but it is crowded compared to what lies between galaxies. We have spoken of how thinly the stars are scattered, each one alone in years of open space. Yet within a galaxy there are at least stars and clouds of gas and drifting dust. The space between galaxies has almost none of that. It is the closest thing the universe offers to true and complete nothing. Consider what fills that intergalactic space. On average, it holds something like a single atom in every cubic meter. One atom alone, in a volume large enough to hold a person. No clouds, no dust to speak of, no stars to give off light, no structure of any kind. Just a thin and almost perfect vacuum, stretched across distances of millions of light-years, emptier than anything that can be made or imagined on the Earth. It is difficult to picture emptiness this complete, The best vacuums ever created in laboratories, the most carefully emptied chambers, still hold vastly more matter than a cubic meter of intergalactic space. The space between galaxies is emptier than our finest emptiness, and it is not a small chamber, but an ocean of such void, surrounding every island of galaxies and filling most of the volume of the universe. Imagine a single beam of light setting out across that space. It leaves one galaxy and travels outward into the gap, and it finds nothing in its way. No dust to dim it, no gas to scatter it, no star to bend its path. It simply travels on and on for hundreds of thousands of years, then millions, crossing an emptiness with no features at all to mark how far it has come. There is nothing to slow it, nothing to catch it, nothing to measure the distance against. This is the purest void of the ladder, and there is a strange peace in it. The space between galaxies is not violent or churning. It is the stillest place that exists, a silence so complete that a beam of light can cross it for ages and never once be interrupted. Nothing happens there. Nothing changes. It is simply distance, held open and quiet, between the rare bright places where matter has gathered. And the galaxies themselves, those islands of hundreds of billions of stars, are small against the gaps between them. The space separating one galaxy from the next is often many times larger than the galaxies themselves. If the Milky Way were shrunk to the size of a coin, the nearest great galaxy would lie across the room, and most of the universe would be the empty air in between, holding nothing at all. There is a quiet thought to rest in here, that emptiness is the true material of the cosmos. We tend to think of the universe as made of stars and worlds, with empty space as the gap between the real things. But the proportions tell the opposite story. The emptiness is the overwhelming majority, and the bright matter is the rare exception. Space is not the backdrop. Space is the substance, and the galaxies are the scattered specks within it. A beam of light, crossing the intergalactic void, carries this truth in its own long journey. For nearly the whole of its existence, that light travels through nothing, between the galaxies, rather than within them. The brief moments when it passes through a galaxy, near the stars and the dust, are the rare exceptions in a journey made almost entirely of emptiness. Even light spends most of its life in the dark, between the islands. To stand inside any galaxy, then, is to stand on one of the rare grains of matter in a universe made mostly of distance. The night sky we see from the Earth, crowded as it looks, is a view from inside one of the few crowded places there are. Beyond the edges of our galaxy lies the true and ordinary condition of the cosmos, which is emptiness, stretching for millions of light years in every direction, holding almost nothing at all. To stand in intergalactic space, if such a thing were possible, would be to stand in a darkness unlike anything on the Earth. There would be no sun, no nearby star, no glow of any kind close at hand. The galaxies would hang in the distance as faint smudges of light, unimaginably far, and all around would be a black emptiness, holding, on average, a single atom in each great volume of space. A person set adrift there would have nothing to fall toward, and nothing to reach. The nearest galaxy might lie 1,000,000 light-years off, far beyond any possible journey, and in every direction, the same near-perfect void would stretch away. There would be no up and no down, no landmark, no current, only the stillness of a place so empty that even the thin gas of a galaxy's interior would seem crowded by comparison. Yet that emptiness is not entirely without its wanderers. Here and there, between the galaxies, drift the rare rogue stars, suns, flung out of their home galaxies long ago by close encounters or by the slow violence of galactic mergers. They travel alone through the intergalactic dark, with no galaxy around them, their nearest stellar neighbors millions of light years away, the loneliest stars that exist. Light is the one thing that crosses this emptiness freely and forever. A beam leaving a galaxy enters the void and finds nothing to stop it, and so it travels on, for 1,000,000 years, 10 million, 100 million, crossing the gap between the islands without ever being touched. The light reaching us tonight from distant galaxies has spent nearly the whole of its long life in this emptiness, between the galaxies, rather than within them. This is why we can see the distant universe at all. The space between galaxies is so empty that light crosses it almost perfectly preserved, dimmed only by distance and stretched only by the expansion of space, never blocked or scattered by anything in the way. The emptiness that defines the cosmos is also what makes it visible, a clear and open medium across which the rare bright places can send their light to one another. The proportions here are difficult to overstate. If a galaxy were shrunk to the size of a dinner plate, the nearest similar plate would lie many paces away, and the room between them would be empty air, holding almost nothing. Scale that picture up to the whole universe, and the galaxies become rare plates scattered through an enormous hall, with the overwhelming majority of the space between them holding only the faintest trace of matter. There is a profound stillness to this rung, perhaps the deepest of the whole climb. Nothing happens in the space between galaxies. There are no events, no changes, no weather, only the slow stretching of the space itself and the silent passage of light. It is the quietest place that exists, a stillness held open across millions of light years, the true and ordinary condition of the universe between its scattered islands of light. And so the space between galaxies stands as the purest emptiness of all, emptier than any vacuum we could make, stiller than any silence we could find. The galaxies are the rare exceptions, the lit plates in the great dark hall, and the emptiness between them is the substance of the cosmos. When we step back far enough to take in many such islands at once, that emptiness arranges itself into a pattern, and the pattern is the largest structure there is. The space between galaxies is the rung where the imagination finally lets go, because there is nothing left for it to hold. In the solar system there were worlds, in the galaxy there were stars, but here there is only the thinnest trace of matter across millions of light years, a single atom drifting in each great volume of the dark. To picture it honestly is to picture almost nothing at all, an emptiness so complete that it defeats the eye and the mind alike. And yet it is the true and ordinary condition of the universe, the substance through which the rare islands of light are scattered. The galaxies are the exception. This silence, this near-perfect void, is the rule. So let the space between galaxies be what it is, the stillest and emptiest place in existence, where a single atom drifts alone in each great volume and light crosses for ages without meeting anything. It is not a void to fear. It is the quiet ground on which everything else is scattered. And when we step back far enough to take in many galaxies at once, that emptiness reveals a pattern, an arrangement so large and so beautiful that it took a long time even to notice it. Zoom out far enough, past single galaxies and past clusters of galaxies, and the universe stops looking random. At the largest scales of all, the galaxies are not scattered without order. They are arranged into a single enormous structure that runs through all of space, and it is among the most beautiful and the strangest things in the whole climb of the ladder. The arrangement builds upward in stages. Galaxies gather into clusters, groups of dozens or hundreds bound together by gravity. Clusters gather in turn into superclusters, greater assemblies spanning many millions of light years. And the superclusters string together into immense thread-like structures called filaments, ropes of galaxies stretched across the universe, some of them hundreds of millions of light years long, woven through space like the strands of a web. Where many of these filaments meet and cross, they form bright knots, the densest concentrations of galaxies anywhere in existence. And between the threads and the knots lie the great empty spaces, the regions where almost nothing remains. Seen from far enough away, the whole universe takes on the look of a foam, thin, bright walls and strands of galaxies surrounding enormous dark bubbles of nearly empty space. This structure has a name. It is called the cosmic web, and it is the largest pattern that exists. Everything we have met so far, every star and galaxy and cluster, is part of it. The Sun and the Milky Way and the whole local group sit on one of its many strands, a single thread in a network that spans the entire observable universe. To see the cosmic web whole is to see the skeleton of everything. The Milky Way's own place in this web was only recognized when astronomers traced the motions of thousands of galaxies across a great region of space. They found that all of those galaxies, including our own, were quietly flowing in the same direction, drawn toward a common region, a gravitational low point that pulls a whole expanse of the cosmos slowly toward itself. Our galaxy is not still. It is drifting, with thousands of others, on a current too slow to feel. By tracing that flow, astronomers mapped the supercluster our galaxy belongs to, and its size is difficult to hold. It spans something on the order of 500 million light-years from end to end, and it contains on the order of 100,000 galaxies. 100,000 galaxies, each one a city of hundreds of billions of stars, all drifting together within a single structure, 500 million light-years across. Now, place ourselves within that figure. The entire local group, our own neighborhood of 50 galaxies, the island that contains the Milky Way and its great neighbor and all their companions, is a single faint streamlet on the outer edge of that supercluster. The whole of our local cluster, already beyond imagining a few rungs ago, is now one small thread among 100,000 galaxies, drifting inward on the slow current toward the distant low point. This is the way the ladder works at every step. What seemed like the whole of things at one rung becomes a single detail at the next. The solar system vanished into the galaxy into the local group, and now the local group itself becomes a faint edge of one supercluster, which is in turn only one node of the cosmic web. There is always a larger structure, and our own place keeps shrinking toward a point. And the cosmic web is not a still photograph. It grows and shifts across enormous spans of time, the filaments slowly drawing matter inward, the bright knots gathering ever more galaxies, the empty bubbles between them widening. Over billions of years, the web sharpens, the strands becoming clearer and the voids becoming emptier, as gravity patiently sorts the matter of the universe into threads and leaves the spaces between them ever more bare. The cosmic web did not arise by chance. It grew from the faintest of beginnings, tiny ripples in the density of the early universe, places where matter was very slightly more crowded than the average. Gravity took those small differences and patiently magnified them over billions of years, drawing matter from the thinner regions toward the denser ones, until the gentle ripples had grown into the great walls and threads and voids we see today. Wherever matter was slightly denser, it pulled in more matter and grew denser still. Wherever it was slightly thinner, it gave up its matter to the growing strands and grew emptier still. Across the long age of the cosmos, this slow sorting carved the smooth early universe into the foam of the present one, with everything gathered along the filaments and almost nothing left in the great hollows between. The strands of the web are not solid ropes, but loose chains of galaxies, strung along invisible threads of dark matter that give the web its underlying shape. The dark matter formed the framework first, drawing itself into a scaffolding of threads and knots, and the bright galaxies gathered along that scaffolding afterward, lighting up the structure that the unseen matter had already built. The web we see is the glowing trace of a darker web beneath it. Our own galaxy's slow drift toward a distant gravitational low point is part of this same great sorting. Whole regions of the cosmos, thousands of galaxies at a time, flow gently toward the richest concentrations of mass, drawn along the threads of the web toward the great knots where the filaments meet. We are caught in one such flow, drifting with our neighbors toward a far-off gathering of galaxies, on a current that will take us billions of years to follow. The supercluster our galaxy belongs to is not even bound together by gravity into a single fixed object. It is a region of common flow, a stretch of the web where the galaxies are drifting the same way, but the expansion of the universe is gradually carrying its outer parts apart, even as gravity draws its inner parts together. The superclusters are not permanent cities but loose and temporary gatherings, slowly dissolving even as they form. To map all of this, astronomers chart the positions and motions of immense numbers of galaxies, building three-dimensional pictures of the web across hundreds of millions of light-years. The maps reveal the same foam-like pattern everywhere, the bright filaments and the dark voids repeating across the whole of the observable universe, a single connected structure of which every galaxy, including ours, is one small part. Seen in these maps, the universe looks less like a scattering of stars and more like a living tissue, a network of bright threads and dark spaces stretched across all of space. It is the largest pattern that exists, the skeleton on which every galaxy hangs, and it took a long time even to recognize it, because we sit within it and can only piece together its shape by charting the distant galaxies one by one. So the cosmic web stands as the grand architecture of everything, grown from the faintest early ripples into a foam of light and darkness spanning the whole universe. We live on one strand of it, in one loose and dissolving supercluster, drifting toward a distant knot. And the dark spaces the web wraps around, the great voids between its threads, are not mere gaps but structures in their own right, among the largest the universe has built. The next rung descends into the heart of that emptiness. Standing back to see the cosmic web hole is the moment the climb reveals its full shape, because here at last the scattered emptiness resolves into a pattern. The voids and the islands were never random. They are the two halves of a single structure, grown across billions of years from the faintest early ripples into a foam of bright threads and dark hollows spanning all of space. Every distance we have climbed has been a journey along or across this web, from our strand outward toward the great knots and the enormous voids. To see it is to see the architecture of everything at once, the framework on which all the light of the universe is hung, ourselves a single dim point upon one of its countless threads. So picture the universe from far enough away to see it whole, as a foam of light, bright filaments and knots wrapped around great dark bubbles, the entire cosmos arranged into a single web of galaxies. We live on one strand of it, in one supercluster, in one small island group, on one ordinary star. And the dark bubbles between the strands, the empty spaces the web wraps around, are themselves among the largest structures of all. The next rung steps into the heart of that emptiness. Between the bright filaments of the cosmic web lie the voids, the great empty spaces, and they are the truest emptiness the universe has built at large scale. These are not small gaps between the threads. They are some of the largest structures known to exist, and they are defined entirely by what is missing from them, rather than by anything they contain. Consider one of the best known of these empty regions. It stretches roughly 330 million light-years across, a span so large that the distances of earlier rungs seem to vanish beside it. Inside a region of that size, ordinary cosmic density would place many thousands of galaxies. This void holds only a few dozen. Where thousands should be, there are almost none, across a gulf of hundreds of millions of light years. When this emptiness was first mapped, almost no one could explain how a hole so large and so empty could have formed at all. The universe was expected to be more even than this, more smoothly filled. A void of such size seemed to break the gentle uniformity that the cosmos was thought to follow, and it took time before the slow process behind it was understood. Voids form gradually, over the long age of the universe. Gravity draws matter out of these regions, pulling galaxies and gas toward the surrounding filaments, and as the matter drains away into the threads, the empty space at the center grows larger and larger. The bright web and the dark voids are two halves of a single process. Everything that gathers into the strands is something taken from the hollows, and so the strands brighten while the voids empty. The voids are not perfectly bare. A thin scattering of isolated galaxies drifts within them, far from any neighbor, and these are known as the void galaxies. They sit in the loneliest places in the universe, with hundreds of millions of light years of near emptiness on every side, and almost nothing nearby to keep them company across the dark. Such isolation shapes a galaxy. With almost no neighbors, a void galaxy evolves differently from one in a crowded cluster. It suffers fewer collisions, draws in less fresh gas, and changes at a slower and quieter pace than the galaxies of denser regions. Loneliness, at this scale, leaves a mark as surely as company does, giving the void galaxies a gentler and more solitary history than their crowded kin. There is something tender in the thought of a galaxy that grew up alone. It is not lost, and it is not in any distress. It simply formed far from everything, in one of the emptiest places that exists, and has made its own slow way across the ages, with no others near. It turns quietly in the dark, holding its hundreds of billions of stars, drifting through a void wider than the imagination can follow, in no hurry and in no danger, asking nothing of anyone. Larger still than any single void is the greatest structure of all, a filament so long that it strains the very rules the universe is thought to follow. Its length is estimated at something like 10 billion light-years from end to end, a span that reaches across a large fraction of the entire observable universe. A structure of that size sits at the very edge of what should be possible. The reason it is troubling is gentle but real. On the largest scales, the universe is expected to look smooth and uniform in every direction, with no single structure standing out across such enormous distances. A filament 10 billion light-years long should not really be able to exist under our best understanding, and some doubt whether it is truly a single connected thing at all. That it may exist is one of the open puzzles the cosmos has not yet explained to us. The voids dominate the universe by sheer volume. Although the bright filaments catch the eye, it is the dark voids that fill most of the space, enormous rounded hollows that take up the great majority of the cosmos. If the universe were divided into equal parcels of space, most of them would fall inside a void, in a region where galaxies are few and far between, and the emptiness reaches for hundreds of millions of light-years. A typical void can span 100 million light-years or more, and the largest reach several times that. Inside such a region, the density of galaxies drops to a small fraction of the cosmic average, so that a traveler passing through one would find only the occasional faint galaxy across an enormous and otherwise empty span. The voids are the great quiet rooms of the universe, far larger than the bright structures that border them. There is a region of the sky where the leftover glow of the early universe appears slightly cooler than its surroundings, across a patch far larger than any single galaxy. One proposed explanation is that an enormous void lies in that direction, a hollow so large that light passing through it is subtly altered, leaving a faint cold mark on the ancient glow. Whether or not that is the cause, the patch is a reminder that the voids may shape even the oldest light we can see. The galaxies that do live within the voids lead unusually solitary lives. With few neighbors to disturb them, they are rarely drawn into the collisions and mergers that shape galaxies in crowded regions. They keep more of their original gas, form their stars at their own unhurried pace, and drift through their enormous empty rooms, largely undisturbed across the whole age of the universe, shaped by solitude rather than by company. It is worth sitting with the loneliness of such a galaxy, gently, because there is a quiet beauty in it, rather than a sadness. A void galaxy is not lost, and not in any peril. It simply formed far from everything, in one of the emptiest places that exists, and has turned slowly there ever since, holding its hundreds of billions of stars, making its own unhurried way through a darkness wider than the mind can follow. Beyond the single voids lie the great walls, the largest bright structures of all, immense sheets and filaments of galaxies stretched across the cosmos. One such wall extends across a span of well over 1 billion light-years, a structure so large it was once thought to be near the limit of what could exist. And then, larger candidates were found, structures reaching across many billions of light-years, pressing against the very rules the universe is thought to follow. Those rules say that on the largest scales the universe should look smooth, the same in every direction, with no single structure standing out across such enormous distances. A wall or a filament many billions of light-years long should not really be possible if those rules hold. That such structures may exist is one of the genuine open puzzles of cosmology, a place where the universe seems to do something our best understanding does not quite allow. So the voids and the walls together mark the outer limit of structure, emptiness, and overdensity, stretched to sizes that strain the imagination and the theory alike. We have climbed from a single warm star to voids hundreds of millions of light-years wide and walls that span billions. And still we have not reached the edge of the observable, for the deepest distance of all is measured not in space, but in time, and that is the rung we climb to next. The voids are the universe at its emptiest and its largest at once, and there is a strange dignity in the lonely galaxies that drift within them. To grow up in a void is to grow up far from everything, with hundreds of millions of light-years of near nothing on every side. And yet the void galaxies are not diminished by it. They turn quietly, hold their stars, and make their own unhurried way through the greatest emptiness the cosmos has built. If there is a lesson in them, it is a gentle one, that distance and solitude are not the same as loss, and that even the most isolated place in the universe still holds its own slow and patient light, turning on through the long dark, with no need to be seen. So the voids and the great walls together mark the largest scales of structure there are, emptiness and overdensity stretched to sizes that test the limits of theory. We have climbed from a single solar system to filaments billions of light-years long and voids hundreds of millions of light-years wide. And yet even here, we have not reached the edge of what can be seen. The next rung is not a larger structure, but a deeper kind of distance, one measured not in space but in time. Every distance in this journey has secretly also been a distance in time, because light is slow and space is large. We have touched this idea at each rung, that to see a far thing is to see it as it was when its light departed. At the greatest reaches of the universe, that idea stops being a footnote and becomes the whole story. To look far enough out is to look back toward the very beginning of everything. consider the most distant galaxies that have ever been observed. They lie more than 13 billion light-years away, and their light has been traveling toward us for over 13 billion years to arrive. This means we see them not as they are, but as they were when the universe was less than 1 billion years old, young and small, and only half-formed. They are infant galaxies, shown to us across almost the entire age of the cosmos. What those distant galaxies look like today, we cannot know. Over 13 billion years they have grown, merged, and changed beyond recognition, and some of them may no longer exist at all in any form we would know. We see only their ancient light, the message they sent when they were young, crossing the widening emptiness for billions of years to reach a telescope that did not exist when the light set out. The universe is about 13.8 billion years old, and to look out into far space is to look back across nearly the whole of that age. Every direction we turn shows us an older view. The nearby galaxies are seen as they were a few million years ago, the more distant ones as they were billions of years ago, and the farthest as they were near the dawn of time. We never see the cosmos as it is now. We only ever see how it was. There is a wall at the end of this view, and it is not a wall of space, but of time. Look far enough, and the galaxies run out, not because space ends, but because beyond a certain distance the light comes from a time before any galaxies had yet formed. Further still, there is a faint glow that comes from everywhere at once, the leftover warmth of the early universe, from an age when the cosmos was so hot and dense that light could not travel freely through it at all. In that early age, the universe was not transparent. It was a glowing fog, so hot and so crowded that light could not move in a straight line without being scattered almost at once. Only after the cosmos had cooled and thinned did light finally break free and begin to travel openly. That moment of release, when the fog cleared and the first light set out, is the oldest thing any instrument can ever detect. The glow from that moment surrounds us in every direction, the most distant thing it is possible to see. It is the edge of the observable universe, the boundary of everything we can ever look upon. And behind it is not darkness, and not an end of space. Behind it lies a time before light could travel, a wall made of the early universe itself, beyond which no telescope will ever see, because there was no light there to send. This is the deepest distance of all, where space and time fuse completely into one. To see further out is only ever to see further back. The edge of the sky is not a place that could be reached by any journey, however long. It is a moment, the moment when light first became free, set at the limit of how far back our seeing can reach. The horizon of space is also the horizon of time. There is a quiet wonder in living inside a view like this. Every glance into the night sky is a glance into the past, a gathering of old light from many different ages, all arriving at once. The universe lays its whole history open before us, not as a story told in order, but as a single layered image, the near things recent and the far things ancient, all shining together on the same dark sky. The light from a distant galaxy carries its age written into its color. As that light crosses the expanding universe, the stretching of space stretches the light itself, shifting it toward the red and beyond, until the most distant galaxies appear not in ordinary visible light, but in the longer waves of the infrared. The more stretched the light, the further it has come, and the further back in time we are seeing, so that color itself becomes a measure of distance and of age. The most distant galaxies yet found are so far that their light has been reddened nearly out of the visible range entirely, detectable only by instruments built to catch that ancient stretched glow. These are the infant galaxies of the early universe, small and irregular and fiercely bright with new stars, shown to us as they were when the cosmos was only a few 100 million years old, in the first chapter of its long history. To look at them is to look across more than 13 billion years, almost the entire age of the universe. We see them not as they are, but as they were at the dawn of galaxies, and what became of them in all the time since we cannot know. They have grown and merged and changed across 13 billion years, and the galaxies they became, if they still exist, lie far beyond our seeing, shown to us only as the infants they once were. There is a limit to how far back even this can reach. Before the first galaxies, before the first stars, the universe was a smooth, glowing fog, too hot and too crowded for light to travel freely. In that age, light could move no distance at all before being scattered, so the early cosmos was opaque, a bright fog with no clear view through it. There were no objects to see, only the uniform glow of a universe too hot to be transparent. Only after the cosmos had expanded and cooled for a long while did the fog finally clear and light break free to travel openly for the first time. That moment of clearing released a flood of light that has been traveling ever since, stretched now by the long expansion into a faint warmth that fills all of space. It is the oldest light there is, the leftover glow of the moment the universe became transparent, and it surrounds us on every side. This ancient glow is the wall at the edge of sight. Look as far as it, and you see the universe as it was at the moment light was first set free, long before any galaxy formed. Look past it, and there is nothing to see, not because space ends, but because beyond it lies the opaque fog, the age before light could travel, from which no image can ever reach us. The edge of the observable universe is this wall of early light. Because the universe has expanded so much while that light traveled, the edge of the observable universe is now far more distant than its age alone would suggest. The oldest light has been on its way for some 13 billion years, but the space it crossed has stretched in the meantime, so that the region it came from now lies tens of billions of light years away. The observable universe is a sphere far larger than its age in light years, swollen by the long expansion. So the deepest distance is the distance into the past, ending at a wall of ancient light beyond which no seeing can reach. We have climbed until distance became time, until the farthest reach became the earliest moment, until the edge of space revealed itself to be the edge of memory. And yet even this enormous, ancient, swollen view is not fixed in place, for the distances themselves are still growing, and that is the last and strangest rung of all. This rung changes the meaning of the whole climb, because here distance and time become one thing, seen from two sides. To look outward has always been to look backward, but only at the greatest reach does that become the entire truth, until the farthest distance is simply the earliest moment. The edge of the observable universe is not a place a ship could ever reach. It is the wall of ancient light, beyond which lies a time before seeing was possible. We are surrounded on every side by the oldest glow there is, the leftover warmth of the moment the universe became clear, and beyond it there is nothing to see, not because space ends, but because time does, at the limit of how far back our looking can reach. So let the edge of the observable universe be what it is, a wall of time at the end of seeing, the oldest light there is, surrounding us on every side. We have climbed the ladder of distance until distance itself became age, until the farthest reach became the earliest moment. And yet even this enormous, ancient view is not fixed. The distances are still changing, still growing, and that is the strangest rung of all. The hardest distances of all to hold in the mind are the ones that are not fixed. Until now, we have spoken of space as though it were a still and settled stage, with the galaxies set at their various distances across it. But space itself is not still. It is expanding, stretching from within, so that the gap between any two distant points grows wider with every passing moment. It is important to be careful about what this means. The universe is not expanding into anything, not spreading outward into some larger empty room that surrounds it. It is space itself that is growing, swelling everywhere at once, carrying the galaxies apart, not because they are moving through space, but because the space between them is increasing. The galaxies are like markings on a surface that is being stretched in every direction. This stretching has a quiet and remarkable consequence. The farther apart two regions of the universe are, the faster the space between them grows. Nearby galaxies drift apart slowly, but very distant ones recede more and more quickly, because there is so much more space between us and them, and all of it is expanding at once. Distance itself adds up into speed. Beyond a certain distance, that growth becomes so rapid that the most distant galaxies are effectively receding faster than light can cross the widening gap. This breaks no law of nature, because the galaxies are not racing through space. Nothing is moving through space faster than light. It is the space itself, between us and them, that is swelling so quickly that the gap grows faster than any beam could ever close it. The result is sobering when it is followed through. Light that those most distant galaxies send toward us today will never arrive. The space ahead of it grows faster than the light can advance, and so the beam falls further behind with every moment, never reaching us at all. Those galaxies have already slipped beyond our reach forever. We can still see their old light, sent long ago, but we will never see them as they are now, and nothing we could ever send would catch them. And the expansion is not steady. It is speeding up, driven by that mysterious dark energy we met at the very beginning, the largest and least understood ingredient of the universe. As the expansion accelerates, the horizon of what we can ever reach or influence is quietly drawing inward. The sphere of the universe we can still affect, and that can still affect us, is slowly shrinking around us across enormous spans of time. One by one, over those immense spans, the galaxies we can see today will fade from view. As the space between us and them stretches ever faster, their light will redden and dim, stretched out by the growing distance, until at last it fades below the reach of any instrument. They will not be destroyed, and they will not move away under their own power. They will simply be carried too far for their light to ever cross to us again. Follow this far enough into the future, and the sky empties. In a span of time so long it dwarfs the present age of the universe, every galaxy outside our own bound local group will have drifted beyond the horizon, carried away by the swelling of space until none of them can be seen. The local group itself, held together by gravity, will remain, eventually merging into a single great galaxy. But beyond it, there will be only darkness. Imagine a thinking being born in that distant age, looking up at its sky. It would see one island of stars, its own galaxy, and around it nothing at all. No other galaxies, no faint smudges in the dark, no sign that the universe had ever held anything beyond that single island. It would ask the same questions we ask tonight about how large the cosmos is and what lies beyond, and it would find the evidence already gone, carried off beyond any horizon. The expansion of space can be pictured with a simple image. Imagine a loaf of bread dough with raisins set throughout it, rising slowly in a warm room. As the dough swells, every raisin moves away from every other raisin, not because the raisins are crawling through the dough, but because the dough itself is growing between them. The galaxies are the raisins, and space is the dough, expanding everywhere at once and carrying everything apart. From the point of view of any one raisin, all the others appear to be receding, and the more distant ones recede the fastest because there is more swelling dough between them. This is exactly what we see from our own galaxy. Every distant galaxy appears to be moving away from us, and the farther off it is, the faster it recedes, not because we sit at any special center, but because the same is true from every point in the expanding universe. Beyond a certain distance, this recession passes the speed of light. The galaxies there are not moving through space faster than light, which nothing can do, but the space between us and them is growing so fast, across such an enormous gap, that the distance increases faster than light can cross it. These galaxies lie beyond what is called the cosmic horizon, the boundary past which the expansion outpaces even light. From those galaxies, light sent toward us today will never arrive. It travels toward us at its full speed, but the space ahead of it grows faster than it can advance, so that it falls ever further behind and never reaches us at all. Those galaxies are not gone, and we can still see their ancient light from when they were closer, but their present selves are sealed away from us forever, beyond any signal we could ever send or receive. And the horizon is drawing inward because the expansion is speeding up. Driven by the dark energy that fills empty space, the swelling of the universe accelerates, and as it does, more and more galaxies cross beyond the cosmic horizon and out of our reach. The portion of the universe we can still affect, and that can still affect us, is slowly shrinking, closing in around our own small island of galaxies across enormous spans of time. Follow this forward far enough, and the consequences become quietly profound. One by one, over spans of time that dwarf the present age of the universe, the distant galaxies will redden and dim as the growing space stretches their light, until at last they fade from view entirely. They will not be destroyed and will not move away of their own accord. They will simply be carried beyond the horizon, too far for their light to ever cross to us again. In that far future, only the galaxies of our own bound local group will remain in view, the rest of the universe having slipped beyond the horizon into the unreachable distance. The local group itself, held together by gravity, will by then have merged into a single great galaxy, alone, in an apparently empty cosmos, with no other galaxies anywhere in its sky, and no sign that any had ever existed. A thinking being born into that age would look up and see one island of stars, and nothing beyond, and would have no way of knowing that the universe had once been full of galaxies, stretching to the edge of sight. It would ask the same questions we ask tonight, and find the evidence already carried away. We live, by contrast, in an age when the whole web is still open to view, the far galaxies still reaching us, the ancient light still arriving, and that is a rare and quiet privilege of our particular moment in the long life of the cosmos. The growing distances are the strangest of all, because they turn the universe from a fixed stage into something that is quietly slipping away. The galaxies beyond the cosmic horizon are not lost to any disaster. They are simply being carried off by the swelling of space, their light stretched and dimmed until it fades, until in the far future the sky holds only our own island and nothing beyond. There is a gentleness even in this. We happen to live in an age when the whole cosmos is still open to view, when the far galaxies still reach us and the ancient light still arrives. That window will not stay open forever, and its openness now is a quiet gift of the particular moment we were given. There is a gentle thought to rest in here, rather than a grim one. We happen to live in an age when the universe still shows us its full extent, when the far galaxies and the ancient light still reach us, when the whole web is still open to view. that will not always be so. And that makes this present age, this long window in which the cosmos still reveals itself, a kind of quiet privilege, a time when the distances, however great, can still be seen and climbed. We have climbed the whole ladder now, from the warmth of our own star to the wall of time at the edge of seeing. It is worth gathering the journey together and asking, gently, what all these distances finally mean. The universe is large, that much is plain. But it is not large in the way of many things. It is large in the way of almost nothing, stretched across emptiness that has no comparison in ordinary life. Set the rungs of the ladder side by side. The solar system, too wide to cross in a human lifetime. The Oort cloud, 30,000 years of flight to traverse and never yet seen. The nearest star, 70,000 years away. The galaxy, 100,000 light years across, mostly empty between its thinly scattered suns. The nearest great galaxy, 2.5 million light years off, its light older than our species. And outward still, the superclusters, the filaments, the voids, and the ancient glow at the edge of everything. At every rung, the same shape appeared. There were rare gatherings of matter, the planets and stars and galaxies and clusters, and around them far greater stretches of emptiness. The bright places were always the exception, and the distance between them was always the rule. The deeper we climbed, the more clearly the true substance of the universe revealed itself, and that substance was not matter, but separation. We sit, as we have seen, on one planet, orbiting one star among hundreds of billions, in one galaxy among trillions, near the edge of one spiral arm, in the quiet middle of everything. Our whole world, our whole history, every life that has ever been lived, has unfolded on a single small grain of matter in a universe made overwhelmingly of distance. The crowded sky we see at night is the view from inside one of the few crowded places there are. And the deepest truth of the climb is this: the defining feature of the cosmos is not abundance. It is separation. The stars, the galaxies, the filaments of the great web, all of them real and all of them luminous, are a thin, bright framework strung around an emptiness that dwarfs them entirely. The bright matter is not the universe. The distance between the bright matter is the universe, and the light is only the rare exception scattered through it. What lies beyond the edge we can see, past the wall of time and the horizon of the expansion, we will never know. The distances there are not merely great. They are permanently closed to us, sealed off by the slowness of light and the swelling of space. There are galaxies whose light will never reach us, and ages of the universe we can never look upon. The cosmos keeps a portion of itself forever, beyond our seeing. And there is a strange peace in that, rather than a sorrow. The emptiness is not a threat. Nothing in all those distances is rushing toward us, because the distances are far too great to cross. The void is patient and still, arranged this way since the beginning, holding the bright islands gently apart. To understand its scale is not to be frightened by it, but to feel how much quiet room the universe has made, and how rare and warm our own small lit place within it truly is. Think of the cosmos, then, as an enormous and patient house, mostly dark, with its lit windows set very far apart. In one of those windows, on one small world, around one ordinary star, we happen to sit, awake for a little while, looking out into the long distances. The separation that defines the universe is also what makes each lit window precious, each gathering of light a rare and quiet wonder against the dark. Somewhere out there, as we rest tonight, a galaxy drifts alone through a void hundreds of millions of light years wide, turning slowly, in no hurry, asking nothing of anyone. Somewhere, a beam of light crosses the emptiness between galaxies, finding nothing in its way, traveling on through the stillness as it has for millions of years. And somewhere the far galaxies are slipping gently over the horizon, carried off by the growing space, while their old light still reaches us for now. It is worth saying plainly how strange our own situation is, now that the whole ladder lies behind us. We are gathered on a single small world, around a single ordinary star, in the thin bright plane of one galaxy among trillions, drifting on one strand of a web whose dark spaces dwarf its bright ones. Everything that has ever happened to anyone has happened here, on this one lit grain, in the quiet middle of an emptiness too large to cross. And the emptiness has been the constant companion of the entire climb. At the scale of the solar system, it was the gap between the worlds. At the scale of the galaxy, it was the gap between the stars. At the scale of the universe, it was the gap between the galaxies, and then the great voids, and then the swelling space that carries everything apart. At every rung, the bright things were rare, and the distance between them was the rule. This is the quiet truth the ladder was built to reveal. The universe is not mainly a collection of things. It is mainly a collection of distances, a great architecture of separation, with matter scattered through it as the thinnest of exceptions. The stars and galaxies are real and luminous, and worth all our wonder, but they are the foam on the surface, and the emptiness beneath is the substance of the whole. There is a temptation to find this lonely or cold, and it is worth meeting that temptation gently. The distances are not a wound. They are simply the shape of the place we live, the way the cosmos has arranged itself across its long history. And the very size of them means that nothing out there is rushing toward us, that the emptiness is patient and still, that our small lit corner is held safely apart from everything else by gulfs too wide to ever be crossed. The separation is also what makes each bright place precious. Because the lit windows of the universe are set so far apart, each one is a rare gathering against an enormous dark, a place where matter has, against the general emptiness, come together into stars and worlds, and perhaps, on at least one small grain, into living things that can look up and take the measure of it all. The rarity is not a poverty. It is what makes the light worth noticing. Think of the cosmos, then, as an enormous and patient house, mostly dark, with its lit windows very far apart. Most of the house is empty room, the great void between the galaxies, holding almost nothing across millions of light years. And here and there, scattered thinly through the dark, a window is lit, a galaxy turning slowly, a star burning quietly, a small world where someone happens to be awake for a little while, looking out. We sit in one such window tonight, on one such world, around one such star. The far galaxies are slipping over the horizon. The ancient light is still arriving. The void galaxies are turning alone in their enormous empty rooms, and the whole great web of light and darkness holds its slow and patient shape around us. None of it asks anything of us. It is simply there, enormous and quiet and far away, the long, calm distances of the universe, holding their stillness through the night. When the whole ladder is laid out behind us, the feeling it leaves is not smallness, but a kind of calm belonging. We are one lit window among the few, on one small world, in the quiet middle of an emptiness too large to cross, and that is not a misfortune, but simply our place. The distances hold us apart from everything, and in holding us apart, they keep us safe, patient, and still. There is nothing to reach and nothing to fear in all that openness, only the long, calm shape of the universe stretching away in every direction. To know its true size is, in the end, a way of resting more deeply within our own small and luminous corner of it. And so we let the distances be what they are, not a threat, but the quiet shape of the place we live, a great house with its lit windows set very far apart. Somewhere out there, a galaxy drifts alone through a void hundreds of millions of light years wide, in no hurry, asking nothing of us. Let your breathing slow. Let the great distances settle into stillness behind your eyes. Sleep well, and good night.